purpose of this training is to help you understand the basics of energy-efficient lighting. In order to identify energy-efficient solutions, you first need to understand the key elements of lighting design and then apply those concepts to energy efficiency. While it is not possible to provide a complete lighting training in a short session like this, we will provide you with additional resources for the elements discussed. Additionally, this session will cover LED technology and discuss why this particular technology has become such an important part of today's energy-efficient lighting portfolio. Lighting can fulfill many objectives, including creating an atmosphere or mood, adding aesthetic beauty to complement the architectural design, or increasing safety or security. However, the primary function of lighting is to provide the appropriate light level and uniformity for the task to be performed by the people occupying the space. The next module in this training will include more information on light levels, but in the simplest terms, different tasks require different light levels. We can all understand that a surgeon performing brain surgery will require higher light levels than a person walking down a hall in an office building. To learn more about lighting design, Northwest Trade Ally Network offers a more comprehensive in-person training on Beyond One-for-One, available to all members. Regardless of the needs of the space or the objective of the lighting design, the goal of energy-efficient lighting is to provide the appropriate light levels and appropriate uniformity in the most efficient way, which in turn leads to the lowest utility cost per square foot. This goal can be met through several design approaches or a combination of approaches. One approach to reduce energy use is to reduce the wattage per square foot. Many incentive programs focus on this approach, offering incentives to reduce the wattage of each fixture through more efficient technologies such as high-performance T8 systems, reduced wattage T8, or light-emitting diode, or LED, technology. Energy efficiency can also be achieved by using fewer fixtures or fewer lamps per fixture. Regardless of the methodology, it is extremely important to make sure that the end design still provides the appropriate light level and uniformity. Many manufacturers provide free lighting software to help evaluate light levels, uniformity, and energy-saving alternatives. A second approach is to get more of the light out of the fixture to the work plane where the light is needed. This is accomplished by using more efficient luminaires or fixtures. More light, or lumens, delivered out of the luminaire means less wattage, and possibly fewer luminaires will be required to meet the lighting requirements in a space. This is one reason light-emitting diode, or LED technology, is at the forefront of energy-efficient lighting. With proper luminaire design, the directionality of LEDs results in less light loss within the fixture, resulting in more light delivered with the same or fewer watts. A third approach is to limit the energy use through controls. Examples of controls include time clocks, occupancy sensors, vacancy sensors, and dimming controls. Based on a preset schedule, a time clock shuts lights off when the space is not in use. In a facility with rigid preset hours or for outdoor lighting, this is a great way to save energy. Astronomical time clocks automatically adjust to seasons, and some even adjust daylight savings time. Vacancy sensors detect when a space is no longer occupied and automatically turn lights off. Proper placement and technology selection reduces false triggering. In private offices and conference rooms, using wall-mounted manual on, automatic off systems may be the most appropriate selection. In classrooms or gyms, ceiling and/or high corner mounted automatic on may be best. Certain spaces, such as conference rooms and copier rooms, will have a higher percentage of savings than spaces occupied a larger percentage of the time, such as open office areas. It is important to select the appropriate technology, passive infrared, ultrasonic, microphonic, or dual technology, as well as the proper sensor location and coverage for the space in order to achieve the desired energy-saving results without the inconvenience of lights turning off while the space is still occupied. Dimming controls not only help adjust the light levels to the appropriate levels for the task being performed, but they also reduce energy usage in the dimming mode. Daylight harvesting, or reducing light levels based on the amount of available daylight, is another way to reduce energy usage. The most important consideration in dimming control selection is determining the compatibility with the light source. While many products, including LED, will promote dimmability, not every dimmer will work with every technology or product. Both linear fluorescent and compact fluorescent systems require dimming ballasts in order to use dimming controls, but not all dimmers work with all ballasts. Therefore, it is important to work with manufacturers to determine the right control for the specified light source. To learn more about controls, the Northwest Trade Ally Network offers a more comprehensive in-person workshop on controls available to all members. While not appropriate for every application, LEDs have taken a strong lead in the region's energy efficiency programs and success. LED technology is available as replacements for standard A-lamp incandescent, flood lamps, outdoor lighting, recessed cans, linear fluorescent tube replacement, and new interior and exterior fixtures. The interest in LED as an energy efficiency technology is based on the potential for LEDs to surpass almost all other light sources in delivering more lumens per watt, thus reducing energy usage. A second feature, as mentioned earlier, is the ability in some luminaire types to deliver more of the light to the work plane due to the aiming of the individual diodes. This means less wattage is needed to deliver the same results as less light is lost in the fixture. Like all emerging technologies, criteria needed to be set to make sure quality was not lost for the sake of energy efficiency, and products were actually performing as manufacturers were claiming. This began with Energy Star specifications for replacement lamps and several luminaire types, including decorative fixtures and recessed downlights. The Design Lights Consortium, DLC, establishes criteria for many of the commercial categories not covered under Energy Star and lists the products on the Qualified Product List, or QPL. While products await qualification for Energy Star or listing on the DLC QPL, pending testing results, LED products can get a temporary listing by the Lighting Design Lab based on the specification sheets. Most regional programs recommend or require listing by one of these sources in order to receive incentives. Regardless of listing, be sure to evaluate the products for the particular application based on light level, uniformity, and cost effectiveness for your customers. To learn more about LEDs, the Northwest Trade Ally Network offers a more comprehensive in-person workshop on emerging lighting technologies, available to all members. In conclusion, a basic knowledge of lighting design, controls, and technologies will help you determine the best lighting solution for each customer. Once you know what your customer needs as the end result, you can determine the best way to deliver the results with the lowest energy use, creating an effective, energy-efficient lighting solution. To find additional resources, the latest news, and to access the list of upcoming Northwest Trade Ally Network workshops throughout the region, visit www.nwlightingnetwork.com. That's nwlightingnetwork.com.
You've just completed Module 2, Basics of Energy Efficient Lighting. Please consider viewing the additional 4 modules in Northwest Trade Ally Network's Basics of Energy Efficient Lighting video series. Module 1, an overview of energy efficient lighting in the Pacific Northwest. Module 3, Basics of Retrofit in Place. Module 4, Best Practices for Site Audits. Module 5, Utility Lighting Calculators.